Hello, and welcome to a course on exam techniques for Grade 11 Mathematics. Thank you for the opportunity to share knowledge on terms of algebra and how they produce a solution in mathematics. Here, the focus is on how to use the BODMAS rule to simplify various quadratic or exponential expression into their standard forms. Ultimately, singular values of a mathematical expression are obtained as a solution to a standard form. Now, let us see how all this comes together in a typical exam session. Suppose you are given a quadratic equation which is formed by a product of x and 2x plus 1 equals 0. These two factors are used right away to solve for x, such that either x equals 0 or 2x plus 1 equals 0. Therefore, x equals either 0 or negative 1/2. Suppose you are given a quadratic equation of the form 5x squared plus 2x minus 6. To solve for x, note that the equation is already in standard form and its solutions are irrational. Therefore, a quadratic formula is used to obtain solutions to this equation. To use the formula, note the value of a equals positive 5, then b equals positive 2, and then c equals negative 6. Substitute these values into the formula, as shown in this slide. Evaluate this formula using a pocket calculator, considering first a positive square root so that x equals 0.91. Then consider a negative square root so that x equals negative 1.31. Suppose the quadratic inequality of the form 2x squared minus 2 greater than or equal to 3x is given. To solve for x, it is necessary to obtain both x and y intercepts. For x-intercepts, assume equality and proceed using a standard approach of factorizing. The standard equation is given by 2x squared minus 3x minus 2 equals 0. Next, the two factors of the equation are 2x plus 1 and x minus 2. Therefore, critical values of x equal either negative 1 over 2 or positive 2. Now, for y-intercept, let x equal 0. Then y-intercept equals negative 2. Note that a given quadratic equation is greater or equal to 0, while y-intercept is less than 0. So, accordingly, using critical values of x, the solution is in the interval x less than or equals to negative 1/2 and x greater than or equal to 2. Consider an equation given by a square root of a sum of 2x plus 5 minus 3 over a square root of a sum of 2x plus 5 equals negative 2. To solve for x, it is necessary to first naturalize all exponents. That is, multiply every term in the equation by a square root of a sum of 2x plus 5. Note that a square root of 2x plus 5 equals the sum of 2x plus 5 exponent 1/2. Then the equation simplifies as x plus 1 equals a product of negative 1 and the sum of 2x plus 5 exponent 1/2. Now, square each term in the equation, and then, using the BODMAS rule, the equation simplifies to a difference between x squared and 4. A factor for this quadratic equation is either x minus 2 or x plus 2. Therefore, x equals positive 2 or x equals negative 2. Lastly, it is necessary to test if the square root function is valid, that is, if 2x plus 5 is positive. When x equals negative 2, then the test function is positive. When x equals positive 2, then the test function is also positive. Therefore, both values of x are valid. For simultaneous equations, it is necessary to obtain singular values for both x and y. First, Label a linear equation given by x plus y equals 2 as equation number 1. Then, label a quadratic equation given by x squared plus 3xy plus 8 equals 0 as equation number 2. From equation 1, let x equal 2 minus y. Label this as equation 3. Then, substitute equation 3 into equation 2 and simplify to obtain negative 2x squared plus 2x plus 4 equals 0. Next, take out negative 2 as a common factor in the equation. Then, the standard quadratic equation is given by x squared plus x minus 2. A factor for this equation is either x plus 2 or x minus 1. Therefore, x equals negative 2 or x equals positive 1. To obtain values of y, substitute values of x into equation 3. When x equals negative 2, y equals positive 4. When x equals 1, y also equals 1. Consider the roots of a function f at x such that x equals a fraction with a numerator given by 4 plus or minus a square root of 16 minus a product of 4m and negative m plus 5. The denominator given by 2m. To determine values of m for which x is non-real, it is necessary that the square root function is negative. That is, x will be non-real when 16 minus a product of 4m times negative m plus 5 is less than 0. To obtain critical values of m that satisfies this condition, assume equality. The equation will simplify as shown on the slide to m squared minus 5m plus 4 equals 0. Then, critical values are m equals 4 or m equals 1. Therefore, x will be non-real if 1 is less than m and m is less than 4. Lastly, given f at x equal to the square root of negative x squared plus 4x plus 12, show that the maximum value of x is 4. Initially, take out a common factor of negative 1 from the square root function, and then, for simplicity, define a new function g at x equal to x squared minus 4x minus 12. Now, note that f of x is equal to square root of negative g at x. To get the maximum value of f at x, first complete a square for g at x. The first step is to add a 0 in disguise of a constant from a middle term. That is, add and then subtract a square of negative 4 over 2. Then simplify the expression as shown on the slide. From the expression inside curly brackets, notice that x squared minus 4x plus a square of negative 2 equals a square of difference between x and 2. Also note that the other term of g at x is constant negative 16. This is also its maximum value. It follows that maximum value of f at x is at square root 16, that is, at 4. I hope you enjoyed my thoughts on exam techniques for mathematics questions on algebra. Please subscribe to our channel, like this video for more likewise, and share it with like-minded friends. See you next time!